So black holes, they can be small or they can be very, 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 very massive. Stars can be small or very, 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 very massive. That's it. There's no in between. It's the sun is considered a dwarf star. Red dwarfs are considered dwarf stars. That's main sequence stars, and then supermassive, hypermassive. Black holes are the same. Little stars make little black holes. Supermassive, hypermassive stars make massive black holes. There's no difference. There's no in between. There's no little medium-sized ones. There's no mid-range. So because there's nothing mid-range to make them out of. And if you have a bunch of little black holes that all eat each other, that very rarely happens, but big black holes eat each other all the time. If you have a bunch of little black holes eat each other, you don't really get that medium-sized black hole. You know, the little ones get eaten by really big ones, and the really big ones get really bigger and bigger and bigger and bigger. So what else do y'all need to know about black holes? There's so much to talk about. What if you fall into a black hole? There's 4 major theories for falling into a black hole. What happens? But first I have to explain a little bit about the event horizon. As you approach a black hole, before you go into the event horizon, the physics is predictable, and mathematically you can actually work with it. It's pretty reasonable. There's this thing called time dilation, and so as you approach the black hole, time slows down for you, but not for the people behind you. And so you look like you're getting slower and slower and slower as you go to the black hole. The people behind you look and you freeze in time just as you get to the event horizon. Everybody outside the black hole watches you just freeze right there. And you never move again. Time has frozen at that spot. You can't proceed forward in time any further. And that's time dilation. And in Interstellar, the movie does a great job explaining time dilation. The Earth causes time dilation with the gravity field it creates. So if you leave the Earth, on the Earth, 1 second takes 1 second. But if you leave the Earth, 1 second takes just a little bit less than a second to happen. And so technically, if you leave the Earth and you travel fast enough, you can go forward in time. They did this experiment. I told you all about this when they had 1 twin on the Earth, 1 twin in outer space, both wearing very, very well calibrated, very well constructed watches that work in gravity and outside of gravity. And they sent this 1 twin around the Earth for a year at 28,000 miles an hour, the escape velocity you need to reach to get off the Earth. You gotta go be pretty quick to get into orbit. And so he was going really fast, and he was a little bit farther outside of the Earth's gravitational field than his brother. And he experienced in a year 1 minute less time. So his watch was a minute behind his brother's. I'm sorry. Yeah, let me say this right. He was a minute younger? He traveled a minute to the future? It just depends on how you think about it, really. It's kind of hard to understand sometimes. Yeah, he's a minute younger than his brother. I mean, in space, over time, your DNA changes, your body weight changes, your bones start to get absorbed back into your body because you're in zero gravity. There's all these effects that happen to this twin, and the biology is a completely different subject than what I'm talking about. But also, you experience less time. You're going around the Earth for a year, but you only age a year minus 1 minute if you're going fast enough and you're far enough away from the Earth. So time dilation is the Earth is slowing time down a little tiny bit. The sun slows time down a little bit more. But a massive black hole is going to slow time down a lot. So in Interstellar, in the movie, they were on that planet with the giant waves, which they wouldn't have been made out of water. If the science were real, those waves would have been made out of dust, but they still would have been there because the heat from the black hole would have evaporated the water, but it would have ground all the mountains into dust, and the mountains would have been traveling as dust mountains, or just like a wave, but made out of dust. But anyway, we don't even go into that science. He spent about 7 or 8 minutes on the planet, and hours passed outside of that event horizon. So everybody else experienced hours and hours of time, and he was just there for a few minutes. So it was really the time dilation was represented very well there. A massive black hole will slow time down a lot. Technically, as you go towards the black hole, the rockets on your spaceship are projecting you through space, but when you reach the event horizon, you change mathematically. We can't tell you what happens physically. Mathematically, you change from a space line in your graphing of space-time to a timeline. So as you fire your rockets with more fuel and more power, you travel more through time than you do through space because you've crossed the event horizon. Now we're talking some bizarre stuff. This is so out there. I can't do a thorough job explaining it to you on video. But instead of traveling through space, you're traveling through time, and that's why some people believe that you can make a wormhole out of a black hole. And you travel through time to the future, somewhere ending up somewhere across the universe. But we can't prove this because anything entering the event horizon to us freezes, is totally just, it stops. Everything is just stopped, frozen in time, and stays that way forever. If we see it fall into the black hole, it just stays right at the edge forever as far as we're concerned. Whatever's going into the black hole experiences time passing, but we can't experience that and then bring the information back because we're stuck inside a black hole. So, gravity well, warping of space-time, time dilation, time has slowed down to the point where everybody outside the black hole thinks you've stopped, even though you still feel like you're experiencing time as you go into the black hole. And then you're crossing the event horizon where light can't escape anymore. Then what? 4 theories. 1, spaghettification. Your feet are closer if you're in a seat pointed at a black hole. Your feet are a few inches closer, maybe a foot closer to the black hole. So they experience millions of times more gravity and begin to stretch away from you. Spaghettification. Your feet stretch away from you. Your body starts stretching out along these very, very, very divergent gravity forces. Like your head is experiencing 1 million times the Earth's gravity, but your feet are experiencing 1 billion times the Earth's gravity. That's 1,000 times more. And so you stretch out into a single molecule wide piece of what we call spaghetti. It's called spaghettification. You're obviously dead at that point, right? I mean, your body is not going to survive that. And then supposedly you go through the black hole as this single molecule wide strand of spaghetti. That's option 1 for how you die in a black hole. All of these options say you die in a black hole. I mean, why? So, oh, no, there's one that says you live, actually. I'll tell you about that one in a minute. Option 2, a fireball. As soon as you cross the event horizon, you experience massive amounts of heat called Hawking radiation. Stephen Hawking got to name it after himself because he's the one that discovered it. It's out there, it's real, it's been measured. And so Hawking radiation could kill you from just pure heat. The black hole just across the event horizon is this massive fireball. Well, we can't see it because the light keeps getting pulled back in from this massive fireball. So we don't know if it's really massively big or if it's the size of a speck. We don't know. But according to Hawking, Stephen Hawking, Hawking radiation kills you just as you cross the event horizon. It is too hot for anything to survive. Everything is turned to dust as it crosses it because the molecules are agitated so much they just fly apart. And let's see, there's spaghettification, death by fireball, wormhole across the galaxy. So you go in and you are no longer traveling forward through space. You're just going to sit right there and you travel forward through time and space, and you kind of, it's tough to explain. And then somehow on the other side of the galaxy you come out of another gravity well of some kind, maybe a reverse gravity well. There's black holes, we found those, we've seen one, we have pictures. White holes should spew everything out as opposed to black holes which take everything in. Maybe they exist, maybe they don't. So the theory is you can go through the galaxy in an instant, like not experience any time passing at all, boom, you're on the other side of the galaxy. You come out a white hole or something. We don't know what. And there you are. You've traveled across the galaxy in an instant. That's the third theory for how you pass through a black hole. And the fourth theory is you travel from our universe into a black hole and out a white hole in the next universe over, or 3 universes over, or a few universes past that. We don't know. This is crazy, crazy math that shows that our universe was created by what might be considered a white hole. So a black hole in some universe pulls in a bunch of matter. A white hole spews it out into another universe, and that may have been the Big Bang. Maybe our universe was created in a black hole in another universe. It'd have to be a pretty darn big black hole, because there's a lot of mass that came out of it. Compared to our universe, it would be a big, massive black hole. And so, theoretically, if we go into a black hole in our universe, we come out in another universe, and all of the matter that gets spewed out into that universe makes the planets and stars for that universe. Maybe every black hole that starts here is a universe beginning somewhere else. We don't know. Those are your 4 theories for what happens when you go through a black hole. Basically, there's no way to survive. Even if you go through a wormhole through time and space and end up on the other side of the galaxy, you're still going to be a mass of jumbled particles. And if you go into another universe, your particles will be scattered, and then you'll turn into stars and nebulas, planets, and so forth. We don't know. So I'm going to make this into 2 videos. This is definitely going to be 2 videos worth of information right there. And then I'll probably make another one on black holes later, because I'm not done yet. But that's enough for now.